Dear viewers, welcome to the RBS Mathletics digital class video. I humbly request you to subscribe to this channel so that you will receive all updates well on time. Thank you.
Okay, we shall now discuss the law of logarithm. So you can see that this is the law of logarithm. So the law of logarithm, so this is the log of base a, and for the product of numbers x and y, and it is found that log of x to base a plus log of y to base a again. So this is one of the law of logarithm. And this is good to understand the proof of how left side equals to right side. So in this case, you can suppose for the proof, you can suppose that let log ax equals to m and log base ay equals to n. Okay, so we have supposed that log base ax is m and log base ay is n. Now, by using the conversion way of log to exponential function, so we shall convert that into the exponential function one by one. So here, if you convert this logarithm function in terms of exponential function, and in that case your x is going to be here a to the power m, and then here y is going to be a to the power n. Now as you see, we are dealing with the product rule, so we shall take the multiplication of x and y. So therefore we have now x times y equals to x means a to the power m, and times y means y means a to the power n, or you'll get that x y is equals to, as the bases are same, the power get added, so power gets added. So when you add them, so it is m plus n. Now in this case, you can apply the definition of logarithm. You suppose that this is one number, this is another number, and this is in the exponential form now. So in that case, by definition of logarithm, we have m plus n. So here m plus n is the logarithm of number xy to base a. That is, we have log base a xy is equals to m plus n. Therefore log a xy equals to m means, you can see here m means, where is it? Yes, here m we have supposed for log x, so we shall write log x to base a in place of m, and in place of n you can write log y to base a, and in this way it is proved. Now if you'd like to see some examples here, so for example, I'm taking example number 1, and for the example number 1, suppose this is log 13 and the number is 2 times of x, then that is going to be equals to, if you use the law of logarithm in 1, then you'll have, you can expand it like this. So in this case you can expand it like this, means it is log x and it is like log y, and in that case you can write log base 13 of 2 plus log base 13 for x. So in this way you can simplify the logarithm function. And I can tell you another example also. So let's take another example, like For example, you can take any base c, so log base c of any number. For example, it is x squared times y times t squared, for example. And if you use the first property of the logarithm, so it is log x times y is x log x plus log y. If there will be another number also, for example z, in that case it will be log x plus log y plus log z. So here we have the three numbers in this case, and if you are going to apply the first law of logarithm, which is for the product form of the number, so here are the three numbers in the product form. So when you expand it, it will be like this. It will be like log c x square for into plus log base c y plus plus for this into, and then it is log base c for t square. So you can see that in your problem area we are going to apply in the same way that we have been doing here in the example. Now we shall discuss about another law of logarithm. So another law of logarithm is that one time we have multiplied, then this time we are going to divide by. So the second law is that log to the any base of x divided by y, or you can say that is log to any base a x divided by y is going to be equals to log x to base a minus log y to base a. Okay, so this is the another property of logarithm. In this case, we have divided one number by another number. When we expanded, our formula is like this. And now we shall see for the proof of this formula. So in the proof for this formula, if you look back to here we have supposed log x equal to m and log y equals to n for the base a. And after converting this logarithm into the exponential functions, we have the terms like this. So here, in order to find the product rule of the logarithm, we have multiplied these two numbers x and y, but at this time we are dividing the number. So therefore we take the division of x and y, so that first we start with x divided by y. So when you write x divided by y, so x is a to the power m, you can see here, and y is a to the power n. So I will write here, this is a to the power m, this is a to the power m, and this is a to the power n, and here it is, because bases are same in the numerator as well as in the denominator, so a to the power is going to be m minus n algebraically. Now here also you can apply the definition of logarithm, where you suppose m minus 1 as one number and x divided by y as another single number. In that case, by definition of the logarithm, you can say that m minus n is the logarithm of x divided y to the base a in this case. So while finding the product rule, we multiply the exponential functions x and y, and for the division of the number we divide the exponential functions x and y here, and that is we have now log base a x by y equals to m minus n, and you have m as, you can see again here, m as log x to base a, so that is log x to base a minus n as log y to base a, n equals to, so it is going to be log y to base a, and hence this is proved. Now we can deal with some example here. So I'm taking example 1 as, let's say you have log of base 3 for 1 divided by 3 in this case. So suppose that the numerator is x and denominator is 3 for any base 3 here. So if you use the quotient rule for the logarithm, you can expand this sort of thing in this way. Just to apply that formula, so it is going to be log of 1 base 3 minus log of number 3 to the base 3. So fortunately in this case we are able to calculate this sort of log values without using the calculator. So in this case you can see here that log of any base for 1 is always 0, and if the number and the bases are the same, we know that this value is going to be 1. So finally you have the value of this log is -1. So this is one of the example. If you'd like to see another example, so let's take another example as log to any base b. For example, suppose that x y by u, for example. Then how do you expand it? Just you use here, you can use both the formula, the product rule and the quotient rule for the logarithm. So first of all, because we are dealing with the division thing here, therefore we use the quotient rule. So in the quotient rule, it is log x minus y. So here log, in place of x we have got y and base is b here, and then because of this division this is minus, then log of u and the base is again b. Now here you can see there is another step where we can expand the log to the base b for xy. So here if you use the product rule, it's going to be log base b x and plus log base b y, and we already have here minus log base b u. So in this way we can apply those law of logarithm to the problem area as well. So here this is only for the examples, and same sort of concept we are going to apply when we go to solve the problem. We can look for another law. That law is called the third law. We name it as third law, and that law is called power rule. You can say that is power rule. Power rule means in the power rule you can see here log to base a, and there is one number, suppose that is power is m. Then what happens? The power will be in front, and then it will be log x to base a. So this is another relation between this kind of logarithm. So where you can see here the base is a, it can be anything, maybe c, d, 19, 11, whatever, it can be anything, but at this time there is power m to this number x. This can be in terms of either constant or variable. So m can also be either constant or variable. So in this case it is good to know how to prove it. So proof for this is like this. So if you prove it, you can just take like let log base a of x equals to n. If you convert that to the exponential form, it's going to be x equals to a to the power n. Now taking power m to the both sides, so I'm taking power m to the both sides here. Why m to the both sides? While proving this, we have to always think about the relation given. So what kind of relations are given there? Accordingly, we have to think in order to get to the result. Okay, now we shall go ahead in the step. Now after this step, it's going to be x to the power m, and it's going to be a to the power n times of m. Okay, now suppose this is nm as a single number, and this x to the power m is also as a single number. Okay, and now you can apply the definition of, by definition of logarithm, we have here n times m is equals to, so n times m is called logarithm of x to the power m and to the base a. That is we can write logarithm of x to the power m base a equals to m times of n, equals to m times of, what is n then? N we have just supposed here that log ax. So n is in fact log ax. So in place of n we can write log x and the base is a. So therefore it is proved. Now if you would like to see the example, we can work like this. So I will say this is example 1, and in example 1 you can take it like I'm taking the log. So in that case let's see how it can be evaluated. So this is log base 3, and you know this 9 can be factorized to the power of 3 to 2. So 3 square. So in place of 9 you can write 3 square. Now you can see, if you compare this result with this result, you can see that 3 is in place of x and 2 is in place of m. Then what happens then? The power will be in front of this logarithm, and we are left with here only log 3 to the base 3. Now you also know that here the bases are same, therefore log value is going to be 1. So therefore you can write here 2 times of this value is 1, so 2 times 1 is going to be 2. So answer of this logarithm is 2. That is, we have evaluated this logarithm and its value is 2 now. You might be interested in looking for another example as well. So just consider the example like this, and here I will write a bit extended form of this product as well as the division of the numbers. So here take log to any base n, and it's going to be x cube times y divided by z. Now let's think. Can you think of it? You have until now the knowledge of 3 laws of logarithm, one as product rule, another as quotient rule, and now this is the power rule. And here you can see you can apply all those rules. So we shall apply the rules one by one. So here log base n, and you can see here x cube y, so we can write x cube y, and for division we can write minus by using the quotient rule of the logarithm, and here log base n, and this is z. So because of the division sign, okay, and we have seen in the law of logarithm in the division form of the numbers. So if this is divided by, here we put negative sign. Now here inside you can see this is x cube and y are multiplied together now. So you use here the product rule. So if you apply here product rule to this bracket for the logarithm to the base n, in that case you will have the expanded form of the logarithm as log to the base n, and this is x cube. In place of into we write plus, and then log y, and the base is n in this case, and we have already this term going on, so it is log z. Now in this case we can apply the power rule. When you apply the power rule, it comes in front of here, and then it is log to the base n x plus log y base n minus log base n of z. Okay, so in this way we apply this power rule, product rule, and quotient rule for the logarithm to the problem area. We now have a few more laws to go there. You can see that logarithm property 4, or you can say the rule 4. So I'm not writing what is that rule. You can say that is the reciprocal rule, how to make reciprocal of logarithm function. You might be interested in another kind of law of logarithm. Say it is base a and b, and that is going to be equals to 1 by log of base b and for the number a. Now just have a look at this equation. So log base a b, when it has been made reciprocal, then what happens? The base and the number positions have interchanged. So this is also one of the law of logarithm, and that may be termed as reciprocal law of logarithm. So if you are interested to prove it, you can do so also. So in order to see the proof, you can suppose any of these numbers. So I'm supposing the first as let log base a of number b is equals to n, and if you convert that into the exponential form, it's going to be b equals to a to the power n. Now at this point I'm taking log to base b to both sides. In that case, it's going to be like this. So b equals to a to the power n, and according to how we mentioned here, you have to put log base b, and here also log base b. That's all right. Now if you move forward to this step, you can see that the given number have the same base. So value of this sort of log is 1, and here if you apply the power rule, your n will be here, and you have log base b a is here. So in that case, what you can see is actually n is going to be 1 divided by log of a to base b, and n you have already supposed as for log a for the number b. So in place of n, you can write, therefore it's going to be log base a for b is going to be 1 by log base b for number a, and this is proved. Now if you would like to see the example based on this law, so in that case, in the example you can see the example is log 15 and this is going to be 13. So when you need in your problem area, you can write log 15 into 13, and then you can write like 1 by log, just interchange the base and the numbers, is going to be 15 and that is going to be 13. So in this way you can apply that to the problem area as well. You can see for another property also, you say that this is one of the law. So this is in fact log of any number, say b to base a, and it is found that if you introduce any number c in between b and a, you can write at the base c of b and times log base b and c. So another property of the logarithm is like that. So you can insert a lot of numbers between b and c, and if you can keep on making chain of such kind of logarithm, then that will be true. And there is another law also that you can see here, like log a base a for b is going to be equals to log, it is b, so you can write here b, and if there is any number introduced here it is c, and then down to that it is a, so we write log of a and with the number c. So if you consider at this point, so this result can be followed from the law 5, because since here log, this is c, sorry, it should be a, so that this is b, c, and a. So if you use the property 4, and then in that property you have seen that log b by a is equals to 1 by log ab. So here this will be going to be, this is log c a, this will be going to be, when you make it reciprocal, it will be the base and the number position will be changed, so it is a and c, and hence if you use this property over here, then you will have the result 6. Okay, now let's summarize number e, which is less than 3 and is greater than 2. So in this case, you know that log of base e is denoted by ln, and this is called the natural logarithm. So in place of writing log of other bases, when we take log of base e, that is going to be natural logarithm, and we can express the laws of logarithm in ln form as well. So first I am taking ln of xy, and then it can be written as ln x plus ln y. Similarly, ln x divide y can be written as ln of x minus ln of y. Thirdly, ln of x to the power m, for example, so it can be written as m times of ln of x. So in this way we can define the law of logarithm in the natural logarithm form also. So in this way we can summarize this law, and other laws can also be summarized like this, where the base is e. Now we shall discuss some examples that how we apply the logarithm to the problem area. So in that case, I have some example here. So first of all, let's take one example. It states that, so in this case we will apply all the properties of logarithm to evaluate this kind of log function. So here you can see, you start from here, so it is log a because we are going to evaluate it, and this is y, and it is cube root of x, so we can write x to the power 1 by 3. Now you apply the quotient rule, then you will have log a y minus, because of this division, and then log base a of x to the power 1 by 3. If you go to the further step here, so log base a y minus, as this is in the power of x, it will be here in front, and then it is times log base a x. Now you can see here log base a y is given as 4, so you can write here 4. This is 1 by 3 times log base a for x is given as 7, so we can write 7 at this place, and now it is 4 minus 7 by 3, so it is 12 minus 7 by 3, and that is going to be 5 by 3. So in this way we can evaluate the logarithm, provided we have knowledge of all the properties of logarithm. You might be interested in another kind of example also, that how we can do this. As for example, I am taking another one example also that will clear how we use the properties of logarithm to the problem area. So in this case, this example says that solve. So this can also be done by using our usual way of solving the simultaneous equations, but here on one additional knowledge that you require is the law of logarithm. So here you have got two equations. So one equation you can say xy equals to 81, this is equation 1, and another equation is log to base x for y is going to be equals to 3, and that is the second equation. So now I am taking log to base x to both sides of equation 1. Then you can write like this. This is xy equals to 81. So at this point we are going to take log to base x here and log to base x here as well. So when I applied this, then what I have at this point actually, if I go to the further step, so here it is xy, that means it is x times y. Then if you apply the product rule for logarithm, it's going to be log x to base x plus log y to base x. And if you are interested, you can just leave it like this, or you can factorize 81. If you factorize 81 in terms of 3, it's going to be 3 to the power 4. And then you see that here in this logarithm, the number and the bases are the same, so its value is going to be 1. Plus you have log of y to base x is 3 from equation 2, so we write here 3, and it is 4 will be in front of here when you apply the power rule to this term. So then it is going to be 4 times of log base x, and this is 3. So you can see in this case 1 plus 3 is going to be 4, so 4 and 4 both sides have been cancelled out. So you are left with log of number 3 to base x is 1, and when you convert that into the exponential form, yes, it's going to be like 3 is equals to x to the power 1. So therefore when you convert that into exponential form, it's going to be x to the power 1 equals to 3, that is x equals to 3. So we have got one of the values from x and y variables. Now we will see for the value of y. So put x equal to 3 in equation 1, or either in 1 or 2. So I'm putting it this time in equation 1 in order to get the value of y. So from equation 1, x value is 3, so I write here 3, then y, and this is 81, and therefore our y is going to be 81 divided by 3, and when you divide 81 by 3, it's going to be 27. Therefore value of x is 3 and the value of y is 27, and this is our answer. Okay, that is all for now.